cool idea. Here's what he did. He took a curve, and he, like ours, and he said, here's my curve. And he actually did the gravity one, didn't he? Remember? The apple falling? Yeah. He wanted to find the instantaneous velocity, but he had to have 2 points to do it. So he said, okay, I've got a point here that I'm going to call x, y. Better yet, x, f of x, where f of x is equal to negative 16x squared plus 100. Same equation, same function, same everything, okay? I want to find the slope through 1 point, but I have to have 2 points to do it. So he thought of a cool trick. He said, what if I pick another point right here? Here's my x. What if I pick a point x, and I pick another point that's really close to x? Wouldn't that be pretty close? Wouldn't that get me close to the right answer? If I pick x and then a point that's really close to x? So here's what I'm going to do. I'm going to pick another point that's really close to x. And I'm going to call it x plus h. How big is h?
A little bigger than that.
Small. Smaller than you can imagine. Smaller than we can put on our calculator. It's going 0.0000000000000000001, right?
How many zeros is that?
How many zeros is that? An infinite number of zeros. We can never put it on our calculator, we can never write it. But it is the smallest number. Everybody follow? But isn't it different than x? It gives us 2 different points, doesn't it? So what's this point going to be? Up here. If this is x plus h, isn't this x plus h f of x plus h? Yeah. There are 2 points where h is a very small number. Now I can find the slope through those 2 points, and it's going to be really close to the slope through xy, isn't it? That's the idea. Now what's kind of hard to understand is how small h is. H is so small that it is exactly equal to 0.
Then it is zero.
No. It's a small number that's exactly equal to 0. I'll prove it to you. Here they are. 1/3 equals what, everybody? Okay. Everybody agree? All right. Let's multiply this by 3. And what do we get? 20? 9, don't we? So how far off is this away from 1? Isn't it 0.00000000000 and so on with a 1 at the end, away from 1? Yep. What's 1/3 times 3? 1. These are exactly equal, aren't they? According to algebra they are. We multiplied by 3 on both sides, didn't we? Aren't these exactly equal? Isn't this off a little bit? This is h. H is this number, and it is exactly equal to 0. It's a mathematical trick. It's kind of like when we took the square root of -1. Remember, it doesn't exist, so we just made one up. We said it's I. Since you can't take the square root of a negative number, so we made something up. We made up a number h that happens to be exactly equal to 0, but it's just a little tiny bit off. It has both things. It has its own value. It has value, doesn't it? Does it have value? But it's exactly equal to 0. So it allows us to have 2 points, and yet really, they're the same, aren't they? That's the idea of calculus. Now for the good news. Calculus is very easy to do. Very easy to do, hard to understand. We're going to do calculus. We're going to find what's called a derivative. Half of calculus, first year calculus, is spent doing derivatives and using those applications of derivatives.